Welcome to Chibuzor Mathphysics. Today, in the fourth series of reanalysis, we'll be talking about empty set. Empty set. Set simply means containing nothing. When you say something is empty, it means that it contains nothing. It is the totality of nothing. Nothing is inside. So we are talking about empty set. But in mathematics, this is a bit logical. You have to prove that what you say is true or false, and you must use some certain rules in order to prove that your statement is false or that your statement is true. And we will be doing that using contradiction. You know, in the first series of this video, I tell you what is contradiction. If you are given a certain set that you are to prove by contradiction, maybe you are given that set and the set is irrational. Assuming you are given root 2 and they say that prove that root 2 is irrational. First of all, you assume that root 2 is rational, and if it is rational, you prove to show that your final result will contradict your original claim, because when you say that it is rational, you will find yourself to be irrational, which means that the original statement is true. But here we are talking about empty set, and you are to prove that an empty set is a subset of every set. You prove that empty set is a subset of every set. What is that? It does not really make sense when we talk about it, but the fun of it is because it doesn't make sense. And actually, what makes our life reasonable is not because we do what makes sense. Actually, most of the times we do things that we think they don't make sense, but they are the things that help us understand what is the meaning of sense in the first place. So we are talking about proof that an empty set. For those that are not doing mathematics, you might be thinking, what is he talking about? Empty set. You will know why I am talking about it in a few minutes. Just give me 5 minutes and we are done with this. You have to prove that an empty set is a subset of every set. Let's assume that if possible, let's take our solution. And in our solution here, we can say that if possible, what happened? If possible, let's assume that there is this empty set that is not contained in set A. Because if empty set is a subset of every set, so A is a set. A is a set of some kind of set. So if A is a set, so empty set is not contained in this set. Why? Because if empty set is not contained in set A, it implies that there is a set in this empty set that is not in A. That is exactly what it implies. It implies that there exists some set or some element in A, some element in this empty set that is not in A. That is exactly what we are talking about. It simply means that there is some element in that empty set that is not in A. I don't know whether you are getting. We are to prove that this empty set is a subset of every set. Now, if it is a subset of every set, it means that if you have set A, if you have set B, if you have set C, that empty set is a subset of those sets, every set. But here we are saying that if possible, we are taking by contradiction that this empty set is not contained in A, and that contradicts our definition when we say that an empty set is contained in every set. But we are saying that A is a set, that empty set is not contained in A. And if empty set is not contained in A, it means that there is an element in that empty set that is not in A. Because for A to contain in empty set, and for the empty set to be contained in A, it means that all the elements in empty set must also be in A. But we know by definition that an empty set is just empty. There is no set. When we say that something is empty, it simply means that it is empty. So this statement actually contradicts the definition of empty set, because empty set means that there is no element. When you talk about empty set, this is another way of writing empty set. It means no element. So if there is no element in empty set, it implies that it is a contradiction. It is a contradiction. And if it is a contradiction, it therefore means that empty set is a subset of every set. Make it very visible. And you are good to go. This is exactly what it looks like. And there is nothing you need to do again. The question simply means prove that an empty set is a subset of every set. And we know that by the definition of empty, empty means that there is nothing on it. So we say that we let empty set be contained in some set A. And A here is a set. And we know that according to our definition, if empty set is a member of every set, it means that empty set is also a member of A, which means that empty set is contained in A. But by contradiction, we say that empty set is not contained in A. And if empty set is not contained in A, it implies that there is some element in this empty set that is not in A. Because for empty to be contained in A, it means that every element in A is also in empty. But we know that there is no element in empty set because it is empty. And if it is empty, it is a contradiction, which means that the original statement is true. Therefore, we can say that empty set is a subset of every set. And that is the only way to go, and you are good to go. Watch the next video where we prove to you that we only have one empty set. We don't have two empty sets. It is only one empty set.